So Steef-Jan Wiggers is probably one of the very few speakers who probably hasn't missed a single EventGrid conference as a speaker. And he has a firm footprint in the Microsoft integration community. And Microsoft has rewarded him for his efforts by giving him the MVP title. Well, I suppose for 10 years in a row now, right? Or maybe even more.
12.
12. Oh, look at that. Oh my, yeah. So today, Steef-Jan is introduce us to EventGrid, which is Microsoft's events bus in the cloud. I would say a warm welcome to you, Steef-Jan, and enjoy the show.
Yes, thank you. My audio settings are okay, so that's all good. I prepared a session for Integrate, so it's the second day. Welcome, everyone. I try to think about a really long title, and I think I succeeded with Microsoft Event Bus in the Cloud, EventGrid, the missing piece in Azure Integration Services. So I could have made it even longer, then it wouldn't even fit the page. But what I'm going to talk about is Azure EventGrid. So that's the service I'm going to talk about. It is a part of the Azure Integration Services. And what I'm going to share with you is also a little bit from the practitioner side. So, while working with this technology, also a little bit from the architectural perspective. Benefits, some scenarios I'm going to talk about, some I've implemented myself, some that stem from the Azure Architecture Center and so forth. Lex did a great introduction of who I am. So, I work at HSO, so it's one of the sponsors as well for this event. I'm a technical integration architect, so I still work in the integration space. Azure MVP, that's correct, going for my 12th year. Also writing for InfoQ as a cloud editor. So also writing about different cloud platforms, also looking a little bit to the offerings that other cloud vendors have, also particular in this talk, I will mention a few of those. Organizer of a user group in the Netherlands, the Azure user group. One day organizer of Azure Lowlands together with Eldert, who's going to be on the second day as well, so later today. And also a writer for serverless nodes. Also like running, if you know, not so much running this year, although there's a half marathon in Amsterdam later on this year. So who knows, I can prepare for that one. And hopefully next year I can do Boston and then I've done all the big 6 marathons. So that would be cool. Okay, let's start with something really complex. Let's start really looking at, this technology I'm going to talk about and in a setting of an implementation using the Azure EventGrid. So what I'm going to talk about is, or in this case, this complex scenario, I would say, is Dynamics 365 Finance and Supply Chain Management. So that's a long sentence as well. It used to be Finance and Operations. It has a longer name now. An integration where we would leverage, or at least we're implementing this currently, and we have some live as well, where we're leveraging what's called business events. So this is a new capability, a feature inside Dynamics, allowing us to, when something happens in Dynamics, so a business event, there's tons of business events out of the box available in Dynamics, and you can even create your custom type of business event as well. You can configure those. And once those business events are triggered, it will push that event to an EventGrid topic. So that's what you see with number 1. And to organize or configure this, you also need an app registration and a key vault. For the key vault containing some of the details around the EventGrid topic, which means its endpoint and also its key, and an app registration. So once you configure your business event in Dynamics to have that push to an EventGrid topic, you need to have an app registration and a key vault and such in place for that configuration. And once that's set up, and once a business event takes place, that the business events immediately emitted to the EventGrid topic. And then you see some other symbols and stuff. So number 2 is basically that event is being pushed to one of its subscribers, which is a logic app. And as we learned, the logic app we are using is consumption logic app, so not the standard one. That will use the information inside that event and will go to Dynamics to get additional data. So that's kind of the enrichment it does. Once it's enriched, it will push that message to a queue. So then it becomes more transactional. Another message will pick that message up, and that enriched message, and that enriched message is going to be transformed, that's number 6, to a text file, which subsequently is being pushed towards storage account. So this gets a kind of an ink mixing text file because the system, third-party system, needs to have a typical type of text file so it can start production. And that machine is connected to file storage, which leverages basically Azure Files and the Azure storage account. So this holistically is a complete solution where the starting point is a business event in Dynamics. Okay, let's take a little bit step back and let's dive into some of the thinking behind this architectural style, in particular, event-driven architecture, so EDA, leveraging what you see here, an event bus, meaning that the communication and exchange of data is based on events and is through this event bus. So an API will push an event to the event bus. Through filtering and routing, it will get to another API that will respond to it and subsequently start processing that event and do what it needs to do. What you will have with this type of paradigm, this type of architecture size, that you get more to a real-time type of exchanging of data. It also provides loosely coupling as well because of the messaging mechanism and because of this event bus that sits in between it. Also allowing you to exchange those systems. So you can go to this plug and play type of thing. And that kind of basically summarizes a bit, the event-driven architecture, but then leveraging what's called an event bus. And what are then the events? What kind of events are we talking about? Could be a temperature change. Kind of this pandemic, it's kind of obvious that a lot of people have their temperatures measured, but temperature change in general, it's a fact, something happened, and you can respond to that. Or it's a state of an object that changes. For instance, what I just talked about in that example with Dynamics, an entity changes, leads to a business event, and then you can respond to it. Could even be a change in your Azure subscriptions. So all of these are facts, something happened, discrete events that you can respond to if you want to. And those are events. So given events and given event-driven architecture, is this new? Are we talking about something really new? No, because back in the day, I worked for Bistro quite extensively, and the broker product, which is still used today, it's a great product in one end, on-premise exchanging data, also is kind of this event-driven paradigm a bit. It's like you publish your messages into a message box queue or a message box, and then the subscribers, which can be one or multiple, subscribe to those messages and start dealing with it. Maybe even a mapping and then send them out to systems. So this means that events, or at least then you're more talking about messages, but the event-driven architecture principles are kind of similar because you put BizTalk in the middle of your landscape in a kind of a hub and spoke model maybe, and then you're decoupling all those systems. If you nicely also apply common canonical data models and such, you can completely loosely couple your landscape with a broker in the middle as a central hub for exchanging data. And given the event-driven architecture style, you might be like, okay, when do I use this in general? I've already given it simple, but if you want to have multiple systems process similar events, you can use or at least think about this type of architecture. If it becomes with minimal real-time processing, more or less, so you want to keep your system consistent with data, your system of records, then having an architectural style in this way, this type of implementation can work. Similarly, if you want to do complex event processing, an event leads to a chaining of actions that need to proceed, then also this style can work. And similarly, you can also apply this having high volume and velocity of data in IoT type of scenarios. So there's quite some. If you look at your solution and you want to think about what type of architectural style or what type of solution pattern do you want to use, then event-driven architecture style, at least with those things in mind, can be applicable. And that said, it's like, okay, but what are the benefits then using this? Well, one of the things is speed and cost, because you centrally place all your events to this central event bus, and then you fan out your events to those applications. This means that in a world that we are now connected and it needs to be responsive and you need to be notified easily, that interaction through third-party services is way easier using this type of paradigm by pushing events out and saying notification. If I do an order, I get a notification back, hey, your order is being placed. And then later on, somewhere in time, I get a message, yeah, your order is on the way. And then I get from the one that distributes my order another push notification saying, hey, it's almost here. So those are all event-based type of things. The other thing is that your running costs are lower because you're just using a set of technology and only using when it's applicable. There's only use it when you need to use it, instead of using queues where you do constant polling and such. And the other thing, the benefit what you're getting is resiliency. So if a service fails, you can automatically restart or replay those events from that event bus if that capability is there. So those are quite, I think, the benefits of an event-driven architecture and the benefits from the capability you're going to use. And the capability that we're talking about is Azure EventGrid. So this is a capability you'll find in the Azure Integration Services stack, if I can call it that way. And the concept's pretty easy. You have on one end, you have your event sources, which can be multiple, can be the ones that are inside Azure that support EventGrid as a capability. This can also be custom events, or the events that you create and emit towards an EventGrid topic, and could even be cloud events. I'll dive into cloud events in a second, but those are events based on a certain schema, based on the CNCF, that's the Cloud Native Computing Foundation. They defined a certain schema as well. But a little bit in that. But you push those events to EventGrid, and then there's multiple ways of handling those events. So one end you subscribe to those, but then you can have functions. So you basically get your workload, or you start processing a workload. It could be a logic app, which I just gave an example of, which you can use. You can buffer your events using Event Hub and storage. So your replay capability and even archiving can be done using those type of technology. And it can even be other types of services hooking into the EventGrid topic and subsequently receive those events to handle those. It can even be an automation type of thing. So overall, you can look at it this way. So I found this on the Azure Architecture Center, which is pretty interesting as well. So you can see those events or sources on the left-hand side, pushing events to either a system topic, for instance. Those are the topics that you have embedded into the Azure services supporting Azure EventGrid, or it could be a custom topic you create. So for those business events from Dynamics, you can create this custom topic and then start emitting those events to this topic. And then you have your event handlers, which I already mentioned, but it can be multiple. And leading to that, they will handle the event and then, for instance, can even send out an email or an alert or whatsoever. For those who are unfamiliar or not familiar yet with the Azure EventGrid Service Cell, it basically sits on the concept which is depicted in this slide. So event happens, and those events are just facts, something happened in a event publisher. That's where the event takes place. So that something happens, that event is being pushed by the capability of the service or application itself. So that's why the events takes place. They're being pushed to the topic. That's why the publishers, as you can see, send their events to. And then you have your subscribers on one end that will know, okay, I want in a certain way how they want to receive the events, and then subsequently you have a handler sitting behind it that can react to the event and do whatever it needs to do. For instance, enrich a message by looking at the event data, which contains some entity potentially with an identifier, and then use that type of information to get additional data out of Dynamics. Those events adhere to a schema. So they have quite a particular structure. And it can either be a proprietary one that Microsoft offers with a certain set of properties, as you can see, and there's a data property that contains those unique elements of the event taking place in a certain source. Similarly, the cloud event by the Cloud Native Compute Foundation also has a similar set of properties, but also this characteristic data property containing the elements of the event that has taken place, or at least the source, those are elements. I have an example of that too. So those events, adhering to those type of schemas, are then routed to their subscribers based on what's called filters. And those filters can either be on a subject, they can be on a type, or they can be data, so the elements inside that data itself. And that's an example. So it can either be an event type, can be an event type emitted from an Azure service that supports EventGrid, and then it has certain defined event types, which is an example you see here. It can also be, if you have the storage account and the blobs created, then the blob created is the event type. It can also be that you define in your custom event an event type, and then you can start filtering on those types. It can also be more what's called a subject filter. And with that, you can, for instance, with the blob created, you can, inside a storage account, look at the specific container, and then, for instance, also look at a specific file. It could be a JPEG. And then there's another concept of advanced filtering, meaning that inside a data element, you can also use some kind of expressions and such to do filtering based on what element inside the data. So you can compare this maybe a little bit with content-based routing versus routing on the header information. And that's more on the context. Okay, that said, let's look at some of the event-driven solutions. So I'll give you a bit of background about Azure EventGrid as a service, as a capability, some of the characteristics about it, some of the thoughts behind from an architectural perspective. But how would this look in event-driven solutions? So I already gave you an example with Dynamics, but there's another one. This is one I built with a few colleagues last year, where a company has multiple third-party systems in the cloud, like Salesforce, ServiceNow, another ERP system, and they need to exchange data as well in a more real-time manner to keep data kind of consistent. So let's say an order that's being created inside Salesforce, some of the data also needs to be known in ServiceNow. And the way this is set up is Salesforce is emitting events, so generic events is like this object with this identifier to a logic app that will map that to a proprietary schema. So it will create that event how it needs to be with certain characteristics and push that to a topic. And then you have a handler sitting behind it, which will call, it's a kind of an enrichment type of pattern, at least fetch the data of the change. And then it will push that to ServiceNow. As you can see that the logic apps also are secured. So if you saw Tone van Hout's session yesterday, they're secured in API management. So Salesforce can only through OAuth or an app registration type of mechanism call that service endpoint, at least that's an HTTP triggered logic app. So it can proceed in calling the data from the handle event logic app. And then again, that's also being secured because Salesforce wants a token as well. So in the policies, as you see depicted here, you can get that policy before you can do the operations. And then the outbound is being mapped by Liquid, and that's another policy, and leading to the fact that this will push that information into ServiceNow. But centrally, you see that that event grid in the middle in this solution for this eventing mechanism of exchanging of data between those third-party SaaS solutions. Similarly, and I think you heard it also yesterday, you can have EventGrid, enabled to do some serverless workloads. This is another example you can find in the Azure architecture sample. Basically, there's an interaction between a client application leading to uploading of a transcript. And this uploaded file in a blob storage, of course, will lead to an event saying, hey, I've got this workload. And that's being pushed to an Azure function, which would subsequently get that data, so download it from the blob storage, and then push it to cognitive services doing the analysis of that transcription. So this is another way of setting up workloads when they need to be processed. Instead of polling or looking for these workloads, as soon as it's there, you can process this, or you can even control when it needs to be processed, if necessary. Given that fact, this is another example. You might have seen talks from me in the past where I also talked about this scenario where cars passed a toll booth and then the picture are being taken by those by the toll booth itself, and those pictures are being uploaded to an Azure storage, leading to a blob created event which will trigger, because that event grid sits there, it routes that event to a function which subsequently, like what I just mentioned with the other example I gave about cognitive services, that particular file is being downloaded by the function, pushed towards a computer vision API, which looks at the license plate inside that picture using optical character recognition. Once that's done, it will push another event to EventGrid, which subsequently enables other functions that will process some of that information as well, saving a reference for the picture, see if it's successfully processed. Then there's Cosmos DB, which has all that data. Through another mechanisms, other things happen like storing things, notifying, and so forth. But you see this event grid in the middle triggering these functions and handling those events as well. Given that, let's look at that. Let's just look particularly at how this would work, how this mechanism would work if you upload license plates or pictures of license plates to a blob storage leading to this blob created event, triggering a function, and subsequently having this analyzed. So the way I'm going to demo this is now I'm not going to start anything. I'm not going to change to another environment because it's more about the principle. I want to explain what happens basically. So if I start the stimulator, it will upload those blob files, those license plates to a blob container. This ultimately will end up in the blob container, leading to events being admitted. So this is an example of an event leveraging what's called an Azure EventGrid viewer. So this is something you can download through an ARM template. At least you can enable an ARM template in your subscription, and then you have this enabled, and then you need to subscribe to any type of event you want to subscribe. So in this case, to the blob created. And then you can also receive those events, and then may also look in real time, how do these events look like? And as you can see within the data element, those are kind of some of the characteristics about the blob created event stemming from the Azure Blob Storage account. And it also has a URL in it. And a URL is important because that event is being subscribed to by an Azure function that will leverage that URL to download the content and stream that to that cognitive services API to let it do the analysis, and the results are being pushed back to a queue, as you can see in the output binding, and then there's my same application, or that, the thing I built will pull it, and it will give this result. And you can see the results are those license plates. So I uploaded 5 license plates, and in the text field, this is the response of the cognitive services API that's being pushed back. And then you can see all the license plates. That's pretty interesting. Another thing where what I build and where EventGrid kind of shines is this kind of functional monitoring setup that we created. So the logic app you see on the left just basically gets all kinds of metadata from various processes that are being executed. All those metadata, or all that metadata, is being pushed to a central document store, and that's indexed and such for a portal perspective. So there's also search enabled on top of it, but it also leverages what's called a change feed. So something similar type of technology with the EventGrid, with this mechanism. Something changes in the data, like an update or a delete or an insert, and those changes are being pushed to a function, which then inspects the file and looks if it can find a process with error or error. If so, it will isolate that document into a blob storage account with all the data in it, and it will trigger a blob created event, something that I mentioned quite a few times earlier as well. And it will get the logging metadata and all that stuff, and it will create a nicely formulated email that's being pushed to a functional team. So the team that is basically controlling the system where some error has taken place. And then we'll get a message like this. So an import job. So this has to do with some type of system that has processing a job, processed with errors. It's a dynamics type of issue in this case. So the value, the dimension is not found. So something needs to be done. So the functional people can click on that link and then investigate the error, even go to the target system and resolve what needs to be resolved. And again, this is kind of reactive, and this is something we built 2 years ago with regards to functional monitoring and end-to-end monitoring, more from a custom solution perspective. Given that, there's a few things I think you have to be aware as well when leveraging the Azure EventGrid service. So its subscribers, EventGrid will try to at least deliver once. At least it's a deliver once guarantee. That's just one of the capabilities of this service. So it will, through an exponential backup kind of mechanism, try to emit those events once, as soon as the application or the responsive app says, okay, or function, yeah, I've got it. Then you get an HTTP 200, I believe, back saying, yeah, I got it, and that's fine. If not, then after 24 hours, your event is just not being delivered. And to consolidate that, you can enable that lettering through subscriptions, enable that lettering, leveraging a storage account, something you have to be aware of. The other thing is, please use that EventGrid viewer. It can be initially that you're accepting events, but somehow your filtering is not working, or you want to expect how the events are looking like if you hook certain applications or services up to your EventGrid topic to see, hey, how do those events look like? There's also limitations with regards to how, because the events always send as a kind of an array. Each event's about 64 KB max, but the array itself is 1 MB. So you have to think about these limitations as well. And the other thing is, if you're starting emitting events or even your custom events, don't push all types of data in that data element field. That's not what it's intended for. It's not a message. It's an event. Something happened, and then the responsive application can respond to it. The other thing is that under the hood, so this really is a service technology, there's service fabric underneath. So if you start pushing millions of events to that central bus, it can easily digest, or at least digest those and fan those out to the responsive application. So keep that in mind as well. The other thing is that you can set up EventGrid domains. That's another capability belonging to EventGrid, where you can manage the flow of your custom events to a certain business organization with some fine-grained security control using role-based access and such. And then finally, you also have to remember that there are certain differences in the topic. So you can either have the system topic sits inside the service. It can be a custom or can even be a partner topic. So Auth0, for instance, is a partner of Microsoft that also can emit events to what's called a partner topic. Okay, is Microsoft the only one in this space with this capability? Having an event bus in the cloud, supporting certain messaging type of capabilities that you've heard of, building solution architects and solutions that I just showed you. No, there's competition, because although Microsoft one of the first with Azure EventGrid, some of the other cloud vendors followed suit as well. So AWS, for instance, came with what's called EventBridge. And if you look at that distinctive picture here, you can see, hey, there's different types of event buses that you can set up. A default one supporting services from AWS itself and custom apps. Hey, that's similar to EventGrid. And you can even have a SaaS event bus. So this is more targeted towards the third party that are partnering with AWS and emitting events through that kind for their own things, like I think Datadog and some of the other observability tools, and push events through this SaaS event bus. And then you have these rules, those filters similar as to EventGrid, and then they're being pushed to some of the services you have in the AWS, like Lambda, that's the counterpart of functions, can be Firehose with more of eventing, can be Amazon SNS, simple queuing, or other targets. So given that, I also prepared, a demo for this. Something similar, I just walked through it. An event is being emitted by an application I have built in Visual Studio. It will send the event to what's called a custom event bus inside Amazon EventBridge, so that's how I configure it. I created a rule, and the rule will send the event as a message to a queue, and that's the target. And then, for instance, a Lambda function can pull that queue and do something. I'm just going to show you all the way up to the Amazon SQS. So similarly, I will fire up a console application, and it will send that message to that custom event, and it will say, okay, I got it, and this is the identifier. Keep that identifier in mind. So the way it is, you have an event bus set up, or at least I set up an event bus in AWS. As you can see, it's set up right here, and I've called it my event bus. So it's a custom event bus. And on that event bus, I've hooked up one rule. I defined one rule that once an event comes in, I want to have this event, through my rule pushed to my queue. So the event will be pushed to my queue. So it will be in the queue, and you can already see the message, because once I click, and this is already being done in this screenshot, once I click pull for messages, that message will come to the queue. At least it's already in the queue, but I have to pull it through this mechanism. And if I click on the message, you can see it has that similar identifier again, with some other characteristics, and also details some of the information. The schemas being supported by AWS EventGrid are one end CNCF, so that's cloud events, but also they have what's called a schema registry capability, allowing you to create your own schemas. That said, so AWS is not the only one that has this kind of a capability similar to Azure EventGrid. Also, Google came with what's called Azure Event Arc. So this is, and they came later into the game, so already AWS picked up with their EventBridge, and Google followed what's called Event Arc. Similar paradigm, you have your event sources emitting events, could be services inside Google supporting it, can be a customized application, pushing the events to what's called, it's kind of a pops-up mechanism, but it's push, and it accounts for also EventGrid and AWS. And also based on triggers and filtering, pushes that to what's called a Cloud Run service. And then there's another capability, which is called Trigger Mesh. But this is more, you can see it in the name, EveryBridge. This supports way more types of events, but also from different platforms. Could be even cloud events from Google PubSub, Azure Event Hub. It can be on-premise events from systems. You kind of build your EventBridge through, what you create through an open source type of thing. At least they provide this capability to enable you to set up the EventBridge, listening to those sources, and then pushing them to other sources. Could be cloud native Kubernetes running somewhere in a cluster. Could also be that it's being pushed to services inside other cloud providers as well. So this is more, let's see more a multi-cloud, multi-event type of solution that's available. Okay, let me get to, and I'm still on time, to the takeaways. So I hope this is insightful, and the way I look at the service, the principles behind it, and the modern architectures you can create. And modern, I mean, event-driven architectures, they've been around for quite a while, but based on those thoughts, you can really create these modern architectures using services inside the Azure cloud. And it's even possible in other clouds as well, or even multi-cloud. And I would say, given to the last 3-4 years, I've built solutions with EventGrid that is a proven technology. It works. It works with that functional monitoring. It works with exchanging data between third-party SaaS systems. It works currently when we're working with business events, so it's proven. And making effect, or I'm concluding, and I'm giving that as you as well, that it's a mature service for event-driven solutions. And if you look at the concepts, and if what I talked about, if you think, oh, it's pretty straightforward, and the way you're talking about it, it's not too complicated. In fact, it's not too complicated. You just have to think about it if it fits your architecture or not. But the lower barrier, it has a lower barrier of entry. That's basically what I want to say. There are some resources. There's always, if you do presentations, you always have resources you can reflect on or provide it back to you if you want to look into some of the resources that are available about these services or about the architecture behind it, this technology as well. So you have documentation, you have the Azure Architecture Center, so you can find some examples there. Yesterday there were examples by Beck Lyons who showed an interesting talk, or she did an interesting talk showing that technology as well. You see EventGrid all over because it's a part of the Azure integration services. If you want to learn a bit more, there's some tidbits in service notes. If you want to work with the technology, you want to find a few things. You have InfoQ, which has articles on it or news articles that explain how the other technology work, like the Event Arc and also EventBridge, but also EventGrid is being covered. So all those event bus type of technology are being covered. There's Microsoft Docs, and there's also a nice, interesting Medium blog as well. And there's also, if you're interested, there's an ebook available on ServiceNow. So I've written this. There's a kind of onboarding you on this technology. So it talks about a lot of the things I talked about in this talk, but a little bit more extensively written down with some examples, and also including a walkthrough if you want to do some hands-on experience as well. Okay, given that, I would say thank you for your attention, and I hope you will enjoy day 2 of Integrate. And I'm happy that I'm lost for word a bit, and I'm happy I've been given the opportunity to provide you with this talk. So let's see if there are some questions as well.
Yeah, thank you so much for doing this session again. Indeed, with us.
I also did a recording, and so, so even if this would have break down, then you could have watched the recording. But then again, you couldn't do questions and answers. So
no, not really. Yeah, so indeed, there are a number of questions.
I see Logic App has already some triggers for blob storage or some other services. Why do we need EventGrid additionally? And that's an interesting question. How do I approach this? I'm kind of accustomed using that type of technology. I think I need to own answer this. Maybe the mechanisms underneath are a bit different. Well, I can say this. If you do blob storage and logic app, then it's basically just one-on-one. And if you want to have the blob storage event for multiple handlers, then Event Bridge of EventGrid would be a better option than just listening to the trigger of blob storage itself. So if you have multiple, I would say, handlers, then I'm not sure if the blob trigger that's inside that binding would be the best option. I know that functions and logic app both will support that, but if you have other services, then I'm not that sure. Then another question is, can we see custom event grid topics, or at least, yeah, if you have a custom event grid topic, you load up your event grid viewer, then you subsequently can also create subscriptions in that custom event grid topic you created, and then you can see those as well. So, and in my example, I'm also using a custom topic. And then we have another question. Is the JSON inside the data the same for the event grid schema as for the cloud event schema? No, because the data itself depends on where the event originates from. So each origin, where the data is, where the event is being emitted from, you will see different elements in the data element. So they're not the same. There will be the same for blob creator, where we always have that set of elements. But if it's another Azure service or it's a custom event, it all depends on what's inside that data element. We have another question. Can you make Microsoft Azure event outputs in CNF format? That's a good question by Kostinas. So yes, you could if you map it yourself. Although I think, I'm not too sure, potentially you could even map those in EventGrid itself. I haven't tried that out. Otherwise you have to, in your logic app or function, do that translation. We have another one. How is EventGrid differ from Apache Kafka, since both work topic and subscriber pattern? Well, that's a distributed log technology, Apache Kafka. So that's a bit different if you look under the hood. If you look to the mechanisms between Kafka and EventGrid, those are different. I think Apache Kafka is best to be compared to event hubs, where you push events to multiple partitions and such. There's no really partitioning under the hood that I'm aware of with regards to EventGrid. It's just a topic. Although the topic subscriber pattern does have a similarity with Apache Kafka and even Event Hub, but it's a different type of technology. It's more about event ingestion. Martin Peter says, don't know about blob triggers, but some logic app triggers do polling. Using EventGrid, the polling is eliminated, like for Service Bus, for example. This is more efficient and cost less. That's exactly true. Thanks for answering that. What to keep in mind documenting on Azure EventGrid solution design? Oh, what to keep in mind? Well, I would definitely say one end is maybe security. So it could be that you want to use the domain EventGrid domains, depending on if there's some security aspects, or filtering is another thing that you really have to be wary about. How are you going to set up the filtering? Who's going to, with regards to the domain, you can control who can accept those events. While with EventGrid, you really have to think about, okay, what type of filtering am I going to apply on the topic? And who is going to subscribe to those events? And I even think in a holistically scene where you have all your kinds of applications that have to respond to certain events, that you also have to document, or at least create flows where you have kind of what I would call an event flow diagram. Which events flow to the EventGrid topic to what kind of systems, and how do they need to respond? So you definitely need to think about those types of things you need to be wary of when you do documentation. What is the difference between EventGrid, Event Hub, and Service Bus? And is there guidance? Well, there's an excellent talk by Clemens Fasters yesterday, which basically explains messaging patterns and really dives into, you know, those topics, basically when you use what. Event Hub, ingestion of data, EventGrid for distributing data in a distributed type of architecture style you're going to set up, and having an event respond by multiple subscribers, and then in a push near real-time mechanism, and Service Bus transactional, but there's also some lag in it, and it's more intended for, well, like it's a message, so there's an intent behind it. But with events, it usually is a fact. You don't have to respond to it. You can, however. But I definitely would recommend to look at that session. Can you tell more about EventGrid Viewer? Can we know the reason for unmatched events or publishing filled events, delivery events for troubleshooting? So one end, the Azure portal will provide you some of the details and show you which events have not been, which are unmatched. But to really look into the events itself, that EventGrid Viewer capability can really help. So you can really look at the events that potentially are not being picked up, for instance, by a logic app. Inside the logic app, you can look at the event as well. But if certain events don't arrive, then that EventGrid Viewer could help in troubleshooting as well. So that's why I'm mentioning it as well. What are the future plans on improving this Microsoft event-driven tech? How can we improve even if it's so optimized already? This is something you definitely have to ask the people from Microsoft, what the roadmap is towards EventGrid. And I think there's going to be a roadmap session tomorrow, or at least the future around EventGrid as well, if I'm not mistaken, on the third day of Integrate.
Yeah, one of the last events of tomorrow, on top of my head.
EventGrid seems to be a very good solution for EDA. However, how are these three requirements covered by EventGrid? So I saw this question also yesterday with the session of Backlines about order delivery. I don't think that's possible because it fans out. So if you have to set up, I think maybe one application doing this pattern where it only can receive one event at a time. But I don't think that's really, order delivery is not something I would cater for or think about with EventGrid. Replay of events, yes, then you have to buffer those in event hubs to do the replay. And the schema repository capabilities a bit more sophisticated with EventBridge, with AWS. And potentially, I'm not sure, maybe that's on the roadmap as well, giving a little bit more versatile capability of creating maybe your own schemas, pushing those type of events, adhering to those schemas to a topic, and then respond on that one. Most pool logic app. Using EventGrid, can we manage control the rate number of events sent for, no, there's no rate limiting kind of capability. It will just, because there's service fabric under it, it's really serverless, it will just push those events out as fast as possible. There's almost no lag between it. The latency is pretty low. So to control that, you basically have to buffer those either in a storage account or preferably in event hubs. And then the responsive application next to event hubs itself would then control it. Or maybe it's better than to push those to maybe a queue to get a better sense of controlling the rate number or doing some load leveling from that aspect. Is it possible to connect? Are we out of time? Yes.
Yeah, yeah.
Then I have to
just take this last one, and after that, well, we can.
Is it possible to connect Amazon EventBridge with Azure EventGrid so that an event fired in Amazon can be consumed in Azure? Oh, that's an interesting one. I haven't tried that one out. I think it should be possible. It should be possible to consume that event either through a Lambda AWS service that will push that to an EventGrid, because an EventGrid topic has a URL and also a key to it. Similarly, that's why we're using Key Vault, that kind of mechanism in my first example with Dynamics, because Dynamics needs to know where is the location of my EventGrid endpoint, or it has an endpoint, and what's the key. And those are securely stored inside Key Vault. So that's why it is. But yeah, it's interesting. Maybe I'll spend some time on that. Okay. Yeah, I'll continue answering questions in the Q&A.
Yeah,
and I wish all the other speakers good luck. And I think Wagner is up next. So
that's correct.
Enjoy, everyone, and thank you.
Covey.co